Hello everyone, my name is Andrey. Today we continue learning Python and today we'll talk about background workers. Why do we need them, how to use them, and what are those? Many of you have been working with Celery before, and Celery is a framework or a library that allows you to create background workers. But what are those? Background worker is basically an app that runs in a background, and your users do not have a direct access to that app. So what is the default schema for background workers? You have your normal application, so your normal web server, for example. Your users send requests to your web server, and then your web server somehow communicates with the background worker and sends some messages or some tasks that the background worker needs to execute. So background worker basically executes tasks in the background, and our users do not have direct access to that application. But why do we need them? We need them because there are some tasks that are really slow, that are really hard to execute, or there are some tasks that better be executed in background. And if, for example, your user asks you to create a report for the last 30 years, you can create that report for, let's imagine that you create that report for 30 minutes. So 30 minutes of your time and your report is here. However, when your user sends a request, he doesn't want to wait for 30 minutes because imagine that your page just loads for 30 minutes. And no one will use it. Aside from that, when you send a request to your web server and your web server runs some heavy computation, your web server can lag and other users will have problems with that application. So what do we do in that case? Once again, our user sends a request to that web server saying that I need a report for the last 30 years. Our server, so web server, sends a request to our background worker, and background worker executes all of the computations and then sends the response to the web server, and web server sends the response to the client. But the client can work with our application while the report is being created. So that is the whole idea. We execute some heavy computations, some expensive tasks in the background, and our users do not have to wait. They do not have to do anything. They just send a request. We send a task from our main server to the background application or background worker, and then everything is being done in the background. All right, but what are the characteristics of our background worker? How we can create that schema? So the most important thing is that your background worker should run on a separate application, on a separate server, on a separate cloud, separately from your main application, so on a separate environment. That is the most important, because the whole idea of a background worker is that we run some computations that should not be run in the main application directly. And if our background worker is on the same server, on the same computer as our main application, then we basically do nothing. The same server is being used, and all of the computations, all of the algorithms will run on the same computer, and that's not what we want. So the first thing is you need to deploy your main application and your background worker separately. And then what we need to do is connect our main service and our background worker. So because they are working on separate computers in separate environments, we need to somehow connect them and make them work together. In order to do that, what we can do is use HTTP calls, use TCP calls, use UDP calls. We can do whatever we want, but we need to somehow connect them. For me, the easiest way to do that is using Redis. So Redis is a database, and if you have never worked with Redis before, then I have an introduction video for the database. And that database, what we'll do today, right now, we'll create main service that will send some messages to the Redis database, and our background worker will get those messages from Redis database and will run the tasks on background service node. So kind of like that. Once again, Redis is one of the options. You can use whatever you want. HTTP calls, like anything. You just need to connect those two applications. And the most important thing is that all the expensive computations, all the expensive algorithms run on your background worker. Now let's go to the code and we'll create a simple calculator using our main application, Redis, and our background worker. So let's go to the code.
All right, so here we have two files, main.py, which represents our main application, and background worker.py, which represents our background worker. I split those ideas into separate files because, once again, they should run on separate servers. And what we need to do, the first is install Redis. So I'll open up Docker Yeah, I forgot to do that, but I'll open up Docker, and if you have never seen me work with Redis, then I highly suggest you watch my Redis introduction video. But if you know what Redis is and what Docker is, I'll just run my Redis in a Docker container. That's it. But while Docker is being started, what I can do is pip install Redis. Redis is a library that will allow us to work with Redis in Python. Alright, so here I have my Redis running in Docker. Let's go to the CLI and let's run Redis CLI keys O. Yeah, we don't have anything, so keys O is a command that allows you to look through all of your keys, through all of your entries. Once again, you should know that because you've seen my Redis introduction video, but we don't have anything here. And that's very, very good because we'll start with an empty database. So the first thing that I want to do is import Redis in my main.py file. So right now, imagine that we are writing our backend application. So that's not a front-end application, that's a backend application that talks to another background worker. And we're not talking about front-end and backend in that video. That's very, very important. We're talking about backend that sends tasks to another application. That is a background worker. That's really important. Okay, so what we have here, I import Redis and then I write with Redis as client do something. So context manager with Redis allows us to get our Redis connection to that client variable. We can add our host, port, and all of those settings here, but by default they are localhost, port is 6379, DB is 0, password is none, so those settings allow you to really run your Redis in a default mode. Our host, I don't know if you can, as you can see, our host is localhost, our port is 6379, and I don't need to write anything in here, but if you work with a real project, of course you need to set up all of those settings yourself. Alright, so what we need to do now? Right now I need to get the problem from my user, a math problem from my user, because as I said, we are going to create a calculator that will send those problems to the background worker and will receive our output on our main.py without running any computation whatsoever. Okay, so I have problem as input, and then what we need to do is send the problem to Redis. But how we can do that? There are tons of commands. We can use client.set to just set a key. We can use we can use something like a mapping in Redis. We can use hash tables. We can use anything that you want. But let's think about it. If we want to create a system that allows many users to send their problems and receive answers later, what we need to do is actually set up something that will add problems to the start of our container and get those problems from the end of our container. So what do I mean by that? Imagine that we have a container 2 plus 2, 3 plus 3, 4 multiplied by 5, something like that. And what we're doing here, if a user adds another problem, we can add it at the start. So for example, 1 divided by 1. But when we need to solve that problem in the background worker, we're going to get it from the end of our list. And what will happen? The users will add problems in an order. So we will have our problems sorted by the time the users added them to that container. And we're going to get the problems from the back and solve them, solve them in a queue. And if you know, we are going to create a queue in a Redis. Queue is a data structure that allows you to basically do that. You add, it's basically a queue. I think you know what it is because you watched that video and you worked with queues before. It's like the beginner's data structure. So what we need to do here is create a queue. And in Redis, when we want to create a queue, we can use a list. List is a data structure in Redis, but we can use it to create a simple queue. So what we need to do first is add our problem to the first index of our list. And to do that, we can use lpush. So lpush is a command that allows you to add your entry to the first index of your list. For example, we have 1, 2, 3, and we want to add 4. We're going to add 4 here to the left side because that's lpush, or to the first index, well, to the index to the 0 index. How do you even say it? 0-ish index? I don't know. To the index, we're going to add 4 as the first entry of our container. That's what I meant to say. Okay, and what we need to do here is provide two things, name and value. So values is a mapping, but we are going to provide just one problem because we can have many programs in one push. But for now, what we need to do is provide the name of our container. In our case, it's going to be problems, and value is going to be problem itself. All right, so let's run our code, main.py, and let's write 2 plus 2. I'm going to go to Redis right now, and I'm going to see keys from all. As you can see, we have problems. And if I run lrange problems from 0 to 10, I can see that we have 2 plus 2. Very, very cool. We have 2 plus 2 problem, and now what we need to do is get the problem from background worker, solve it, and send the result back to the user. All right, so I'm just going to copy that code, paste it here, and instead of doing that, so I'm just going to remove all of the things that we need in main.py, and I'm just going to connect to the Redis, and then what I'm going to do is use client airpop. So airpop is a command that allows you to get your entry from the last index of the list. So for example, we have 1, 2, 3, and when I run airpop, what I'm going to do is get 3, return that 3 as the result of that airpop. So problem is going to be 3 in our example, and then I'm going to delete that 3 from the list. So basically, if I run airpop 2 times, I'm going to get 2 deleted, and I'm going to get 1 and deleted as well. And we're going to be left with an empty list. But there is a problem with airpop, because if you have an empty list, airpop will return none. So airpop will return none, and yeah, kind of like that. Airpop returns none. But let's think about it. We don't want our background worker to solve only one problem, and that's why we will probably use while true to solve many problems of our users, of our clients. However, if airpop returns none, then what we basically need to do is use if problem is none, because if problem is not none, it's going to be bytes or a string, and we're going to need to solve it. But if problem is none, that means that our list is empty, and we don't need to do anything because we don't have anything inside of that list. However, problem is none. So what does that mean? Is that we need to check for it if problem is none and continue. So continue with the next iteration of our while true loop. However, that is really, really, really unoptimized, because what we are doing here is we run while true, we get airpop, and we send the command airpop to Redis. Then if problem is none, we continue, we go to while true iteration again, we get airpop, and we're gonna get airpop a lot of times. So we're gonna send airpop a lot of times, and that is gonna impact our Redis server, because it's gonna have to handle lots of commands every millisecond, every second, every hour. However, what we can do is use bairpop. So the difference between airpop and bairpop is that airpop is not a blocking function. So what does that mean is that basically we send our function, it returns the result immediately. If there is no result, we return none. So if there is nothing inside of our list. But bairpop, what it does, it waits until we have a real result. So for example, we have our list 1 to 3. We run bairpop 1 time, we remove 3, we run it 2 times, we remove 2, we run it another time, we remove 1. And now we have an empty list, but we are not gonna just return none. We're gonna wait until we have another entry in here, for example 4, and then we're gonna get rid of that entry. So basically, if our users will send lots of tasks, or lots of problems in that case, we're gonna have lots of things in here. But if none of the users will send anything to our application, then we are just gonna wait. We're not gonna send millions of tasks or millions of commands to Redis. We're just gonna wait until a user, a client, sends another problem to our application. So that's how it works. So bairpop, it has timeout properties in here, but we're basically gonna wait forever. So timeout is 0. And what we need to do here is provide the name of our list once again. So problems here. And basically what we're doing is we're getting problem from our user and we're pushing it to the problems list. Here we are getting the problem from problems list and deleting it, and we delete it later after we pop it from our list. So we basically delete it and return the result of the problem that have just been deleted. All right, I think now it's more clear. Let's print our problem in our background worker, and let's run our background worker right now. And as you can see, problems 2 plus 2. And if I go to Redis and I run arrange again, as you can see, it's an empty array. So it was 2 plus 2 inside of it, but once we ran pop, we deleted, or br pop in our case, we deleted the last entry of our, and the only entry of our list. So here, what we have here, we have an array of problems and 2 plus 2. So problems is the name of the array that is being used, and 2 plus 2 is the entry that we just deleted. So what we basically need is get 1, because we need to get that second entry, so 0, 1, using the indexes, and then decode UTF-8. So decode allows us to get rid of bytes, because as you can see, those are bytes. That's not a string. And now if I run it again, what do I receive? I receive nothing, because we don't have anything inside of our list. But if I run main once again, then I run 2 multiplied by 6, go to background worker, I can see 2 multiplied by 6 as a string. Very, very good. And now if you want to solve that problem, what we can do is basically run eval. So eval is a very, very, very dangerous function, and I have a video on eval and exec functions and why you should never use them in Python. But for that video purposes, we can use eval, just to solve the problem. Okay, so problem, eval from problem, and what we can do here is answer equals eval from problem, and let's print our answer like that. All right, let's run our main, let's add some problem, and let's run our background worker. And 9. So I wrote, I think, 4 plus 5, but we received 9 as the result. Let's actually do it like that. So I'm gonna create while true in my main.py, so the application does not stop after I only write one problem. All right, so now we can have main and background worker. All right, so I'm gonna write 2 plus 2 and background worker. I'm gonna receive 4. As you can see, there is a little bit of a network lag, because we send packets through networks, even though it's localhost, so it's my own computer, but the lag itself is caused by Redis, by Redis module, because that module has or needs a very long time in order to connect to Redis. But if we do it very quickly right now, so 4 minus 5 multiplied by 6, let's do it like that. As you can see, there is no lag, so we receive the answer immediately. Okay, so minus 26, kind of like that. That is the whole minus 26. Oh yeah, because 5 multiplied by 6. Yeah, all right. Yeah. All right, so we receive our answers here. And now what we need to do is send them back to the main.py. There are tons of ways of how we can do that. And in your application, what you're going to need to do is set up a notification system if you have a web application. So you're going to have a notification system that will send notifications to your frontend and will show them to the client, because clients can switch pages while they can stay on one page, but you need to somehow set up that notification system that sends background worker information to main and then to frontend. In our case, what we can do is just use the same idea that we used before. We can use a list in order to send answers to our clients. So client dot, and let's create a list. So once again, I'll push. I do basically the same as I did it here. I'll push from answers. In our case, I'm going to have 2 lists, problems for problems and answers for the answers of those problems. And I'm going to have answer as the entry here. All right, and then let's go to main, or I just can copy it from here, copy all of that. And the only thing that I'm going to do is change problem to answer and problems to answers. And basically we are all set. So I can print, let's print it like that, problem, then equals, and answer. And now let's run our background worker, let's run our main.py. So again, I just used the same technique. I pushed answers to the left of our answers list, and here I pop them from the right of our answers list. All right, so now we don't even have to go to background worker, because we'll receive all of the answers in our main.py. For example, 2 minus 3. And it was really, yeah, the delay was really, really long, but let's try it again. 2 multiplied by 5. As you can see, that's better right now. You are gonna have those delays in production, but those are not as critical, and of course you need to set up at max 300 milliseconds of ping between your servers, but yeah, that's not that critical, and I think that only happens because of the Redis connection, so of the Redis itself, because right now, as you can see, we receive answers relatively quickly, yeah, very quickly, and all of those answers are fine. So 2 multiplied by 3, it's 6, 6 multiplied by 4 is 24. Very, very, very cool. And we can even have very complex operations like 10 in, yeah, 10 squared, 100, kind of like that. So now what we have is a system that allows us to run our computations on background worker and receive the answers on main.py. However, what I need to say I need to say two things. First of all, you should never, ever, ever run your background worker on the same computer as your main.py, because that way you just neglect all of the advantages of your background worker. Yeah, you can just do it in development or in testing environment. But no, testing environment should be as close to production as possible. So it's better to set up different servers to see how all of those things react to each other. Okay, but you can do it in development because you only have one computer, and I don't think that it's going to be very, very comfortable for you to switch between different computers, between different systems. All right, so you can do it here in development as I do it right now. And the second thing is that client brpop and client lpush will not work in normal applications. So the first part with client lpush problems and problem brpop. So the first part where we just send the answer or send the problem to our background worker and get the problem from that problems list. So that part, or even that part, and that part are going to work fine. However, the problems begin when we want to send the answer back. And why is that? Because if our background worker does not work, so let me just show it to you. If, for example, I add 2, so background worker is down, it does not work, it is killed. What I can do is set up 2 problems, 2 plus or 1 plus 2, 2 minus 3, and then background worker will restart, or we'll restart it ourselves, and what it's gonna do is say that 1 plus 2 is 3, 2 minus 3 is minus 1, like that. So those are our answers. However, whenever I add another problem, like let me say 5 plus 5, we're going to have answer as 10. However, the only problem is that here we don't look for 5 plus 5 because we added that we added 5 plus 5 after our background worker was restarted, and we have 3 more things that we need to pop from our answers list. And because of that, we pop only from the right side. Oh yeah, we pop only from the right side and we add to the left side. So it's going to be 10, minus 1, and 3. If that's the case, we're going to say that 5 plus 5, because we pop from the right side, is going to be equal minus 1. So minus 1 is going to be here. Then if I'm going to add another 4 plus 4 here, we're going to say that it's 3. So it's going to be a mess, just because you only pop from the right side. And again, it's going to be fine when you send your messages to your background worker, but it's not going to be fine when you receive those answers. And what you need to do is either set up a mapping, a dictionary, or somehow identify that your answer is really the answer to your problem. Because if you're going to have millions of users, you're not going to be able to quickly brpop from your background worker. Aside from that, let's remember that all of the tasks on background worker should require heavy computation. So you can have a task that will run for like 30 minutes, and because of that, what you are going to have is brpop that will get tasks from other users. So it's better not to use brpop for answers. It's all right for problems. Once again, it's going to be all right for the problems because you add problems and that's it. But it's not going to be all right for brpop as an answer receiving system, because what you need to do here is somehow identify that problem belongs to that, or that answer belongs to that problem. All right, so now I think everything is fine. You can read about all of the Redis data structures in the documentation of Redis or redis.io. And yeah, kind of like that. So that is the whole idea of background workers. We created a background worker ourselves. And thank you for watching. My name is Andrew. Subscribe to my channel. Leave a like, leave a comment, and bye. Bye.